Good morning, dear students. My name is Ferhan Mazher, and today we are studying Cambridge O Levels Physics 5054. Today we have set our hearts to solve a paper 1, and we have selected a paper 1 from the zone 1. The year of the paper is May June 2022, and the number of the paper is 1 1. So this paper 1 is about MCQs. So there are 40 MCQs, and the time allowed for this is 1 hour. So let's start today's paper. Here we go. So May June 2022, and here we go. Paper 1, time allowed 1 hour. A length of copper wire is labeled 0.5 meter. The length is 0.5 meter and the diameter is 0.50 millimeter. Which instruments are most suitable to measure accurately the length and the diameter of the wire? The length of the wire is half the meter. So we can use a meter rule, and the diameter of the copper wire is always measured with the micrometer. So I think length will be measured with the meter rule, and the the diameter will be measured with the micrometer. So I think the B is the right choice. Let's check the if the choice is right or no. Question number 1, I think the B is the right choice. So our answer is right. Okay, so we are going to next question. A driver drives a car at uniform velocity along the road. The driver sees a hazard and applies the brakes. What is the car's motion as it moves through the thinking distance and as it moves through the braking distance? You see, when you during the thinking distance, uh, the speed of the car do not change; it remains the same. And during the braking distance, you have applied the brakes, so the speed is gradually decreasing. So during the thinking distance, the driver only sees the hazard, and he he decides to apply the brake. So the speed will not change during the thinking distance. So during the thinking distance, the speed, the body will be moving with the uniform velocity, and the braking distance when you have applied the brakes. So when you have applied the brakes, the speed will gradually decrease. So deceleration, I think. So and motion through the thinking distance, that will be the uniform velocity, and motion through the braking distance, it will be deceleration. So I think question number 2C is the right choice. So let's check. Question number 2C is the right choice, sir. Okay. The diagram represents the moon in its orbit around the earth. Which arrow represents the direction of the resultant force acting on the moon at the instant shown? You see, the moon is moving in a circular orbit around the earth. So when you move in a circle, the resultant force is always directed towards the center of the circle. So I think A is the right choice. Yes, question number 3, A is the right choice. He says the mass m of an object is related to its weight w and the gravitational field strength g. Which equation shows the relationship? Okay, the weight is equals to mg. Weight is equals to mg. So if you want to find out the value of the m, that will be w by g. So the mass will be equals to the weight divided by the gravitational field strength. So I think B is the right choice. So let's check. Question number 4, B is the right choice. So question number 5 is showing up on your screen, and a plastic cube of density rho is compressed so that each of its sides become one half of its original length. What is the new density of the material of the cube? Okay, so suppose that the density, okay, now the density of that cube is mass divided by volume, and the volume, because it's cube, suppose the length is L. So the volume will be L cube. So the density will be mass divided by L cube. The mass divided by L cube. Okay. Now the new length, when you compressed it, the new length of the cube becomes half of the old length. So the new length will be half of the old length. So the new density will be mass divided by the volume. Volume will be the new length, its cube. So it will be L by 2 whole cube. So it will be mass divided by the L cube divided by 8. When you will write this fraction upstairs, so it will become 8 by L cube. So mass will be equals to, mass into L, 8 by L cube. So the density will be 8 bracket M by L cube bracket close. So the densities of the second, in the second solution will be 8 times the density in the previous situation. So the density will become 8 times the density of the previous situation. So question number 5, 8 density. Density will become 8 times. The density will become 8 times of the previous density. So I think D is the right answer. Question number 5, D is the right answer, sir. 4 glass objects have square base of equal area. Which object is the least stable? Okay, so the least stable will be, I think, C. The base area is in all of them is same, but it has larger mass at a higher at a at the highest point. So its center of gravity will be higher as compared to the center of gravity, the height of the center of gravity for the other objects. So I think the C is the least stable because its center of gravity will be higher because its most mass is concentrated higher. So I think question number 6, C is the choice. Yes. The initial pressure of a volume V1 of a fixed mass of gas is P1. The gas expands at a constant temperature until it has a volume V2 and pressure P2. Which statement about the pressure and volume of the gas is not correct? So we are looking for that statement which is not correct. A option is pressure is measured in Newton per meter cube. The pressure is not measured in Newton per meter cube. It is measured in Newton per meter square. Pressure multiplied volume is a constant. Yes, true in this case when the volume and the pressure of the gas changes, but the temperature remains constant. Then the product of the pressure and the volume that remains constant. Pressure is directly proportional to 1 by V. That is also true. Pressure is inversely proportional to 1 by V basically. But if you use the word directly proportional, then you have to write 1 by V. The ratio of the V1 to V2 is equals to the ratio of the P2 to P1. So this the last option which they have given to us. Let me show you the D part. I want to explain it to you. Let's say this is the D part. He says the ratio of the V1 to V2 and the ratio of the P2 to P1. So when you write them in the ratio, they are equal to each other. You write them in the fraction, then you cross multiply, you get the same P1 V1 equals to P2 V2. So that is correct, okay? So, but we are looking for that option which is not correct. So that is A option. Question number 7, A is the right option, sir. A stone falls at terminal velocity in air. What is equal to the change in the gravitational potential energy of the stone? So you see, when you fall at a constant speed, the gravitational potential energy do not convert into the kinetic energy. It converts into thermal energy. The change in the kinetic energy, no. The change in temperature of the stone, no. The friction between the stone and the air, no. The thermal energy produced, yes. You see one very interesting thing, when you move with the constant speed, the kinetic energy do not increase. So there is no change in the kinetic energy. So A is not the option. B, the change in temperature of the stone. You see the gravitational potential energy is energy, but the temperature is not energy. So B cannot be the answer. C part is not the answer because the friction is a force, it's not energy. D is the right choice. Question number 8, D is the right choice. So let's check. Question number 8, D is the right option. Sir. Okay. Water in a river is used to turn a turbine as the water flows downstream. How is this type of power source described? So we call it hydroelectric power station. So this is called hydroelectric. It's very simple. It's not tidal, it's not geothermal, it's not nuclear. It's A choice, hydroelectric. So let's check. Let's check if this answer is right. Question number 9A is the right option, sir. A load is pulled by a rope attached to a motor. The resultant force exerted by the rope on the load is shown in the diagram. In each diagram, the load moves in the direction of the force shown and takes 10 seconds to travel 1 meter. In which diagram does the motor work with the greatest? Okay. Now the solution is very simple, In the A, the force applied is 12 Newton and the body moved in the direction of the force. And you simply multiply the force with the distance traveled, you get the work done. In each case, the body moved 1 meter. So 12 Newton multiply 1 meter, so it will be 12 joule, and that happened in 1 second. So it will be 12 watt. Here, 8 Newton force is applied and the body moved 1 meter. So the work done is force into the distance. And that will be 8 into 1, and that will be 8. And the time taken is also 1 second. So it will be, the power will be 8 watt. So in the C part, 10 Newton force and the body moved 1 meter. So 10 joule work is done. The power will be work done divided by the time. So 10 divided by 1, that will be 10 watt. In the same way, you have applied 4 Newton force, the body moved 1 meter. So the work done is force applied multiplied the body moved in the direction of the force. So that is 1 meter. So 4 multiply 1, that will be 4 joule. And that happened in 1 second. So the power will be 4 watt. So the question was greatest power. That will be A option. Question number 10, A is the right option, sir. The total energy incident in 1 second on a group of solar panels is 120 joules per meter square. The group of solar panels converts 720 joule of light energy to 120 joule of useful electric energy in 1 second. What is the total surface area of the panel with what is the efficiency of the system? Okay, so 120 joule energy of the light falls on 1 meter square. So 720 will fall on how much area? So let me show you energy. 120 joule energy is falling on an area of 1 meter square. So 720 joule of energy will fall on how much area? So 120 divided by 720 equals to 1 by x. So x will be equals to 720 divided by 120, and the answer will be 6 meters square. So this much is the area. Then their question is, the group of solar panels converts 720 joule of light energy to 120 joule of useful electric energy in 1 second. What is the total surface area of the panel and what is the efficiency? So the efficiency will be the useful output energy divided by the input energy multiplied 100. So let me show you. I have calculated this. Okay. Now the efficiency will be useful output energy multiply 100 divided by the input energy, and that will be the useful output energy is the electric energy, that is 120 joules, and the total input energy is 720, and multiply 100, that will be 17%. 17% is the efficiency. Area will be 6 meters square. And the efficiency is 17%. So what are the options? I think A is the choice. Question number 11, A is the right choice, sir. Yes, A is the right option. A 1000-watt, 240-volt electric device is switched on. How much energy does it use in 5 minutes? So in 5 minutes, uh, the energy is equals to the power multiplied time. And we know the power, and we will multiply with the time, but the time must be in seconds. So let me show you, I have done this. So the power, the energy is equals to power multiplied time, that's 1000 watt. Multiplied time is 5 minutes. So in each minute you have 60 seconds. It will be 1000 multiplied 5 multiplied 60. So it will be 300,000 joules. 300,000 joules. Question number 12, I think D is the right option. Yeah. A building has walls made from wood and steel. What describes the way in which thermal energy is transferred through the wall? So the wall is made of wood and steel. So in the wood, only the vibration of the molecules takes place, and by that the energy is transferred. And in the case of the steel, the vibration of the molecules also take place. Plus, free electron diffusion also happens. The electrons also vibrate on their fixed position, in their fixed position. So conduction through the wood by the movement of the molecules through the wood only. The molecules do not move. Move means they move from one point to another point. That do not happen. Conduction through the metal by both the vibration of the particles and movement of electrons through the steel. Yes, that can be possible. Conduction through the wood by both the vibration and movement of the molecules through the wood. In the wood, we don't have the electrons, which can move around. Free electrons are not available in the case of the wood. Convection through the metal by movement of electrons through the steel only. So I think B looks the best option. So question number 13, B looks the right option. Let's check. Yeah, question 13, B is the right option. A liquid column in a liquid in glass thermometer is 2 centimeter long at 0 degrees centigrade. The column expands by 10 centimeter when heated at 100 degrees centigrade. Measuring from the P, how long is the liquid column at 30 degrees centigrade? Very easy question. So let me show you my solution. This is the formula which we will use. L theta minus L naught is divided by L 100 minus L naught is equals to theta minus 0 degree centigrade divided by 100 minus 0 degree centigrade. So L theta minus L naught is 2 when the ice point, what is the length of the liquid in the thermometer? So that's 2. And L100 will be 12 and L naught will be 2. So L theta minus 2 divided by 12 minus 2 equals to 30 minus 0 divided by 100 minus 0. So it will be L theta minus 2 divided by 10 equals to 30 divided by 100. So just cross multiply, you will have L theta equals to 3 plus 2. So L theta will be equals to 3 plus 2. So this is how you do this question. L theta will be 5 centimeter. I think C is the right option, sir. Yeah, C is the right option. In many applications, a thermocouple is used to measure temperature instead of a liquid in glass thermometer. Which property of thermocouple is a major advantage? You know, the thermocouple thermometer has a very high, means, its range is very large. And it says which property of thermocouple is a major advantage? It is greater heat capacity. It's smaller temperature range. No, it's quicker response time. It has non-linear output. I think C is the right option. It has quicker response time. Question number 15. I think C is the option. So let's check. C is the right option. A liquid in glass thermometer consists of a bulb containing a liquid which expands into a thin capillary tube. The liquid in the thermometer is replaced by the same volume of a liquid that expands more for the same temperature. The length of the capillary test tube remains the same. How does the new thermometer compare with the old thermometer? So now you have removed the mercury from the thermometer and you have put some liquid which expands more than the mercury. So the length of the thermometer is still the same. So because you have replaced it with a liquid who expands more, so I think it's it has greater sensitivity and a larger range. Yes, the range of the thermometer will decrease because now you see you have put a liquid which expands more. So at a less temperature, at a smaller temperature, at a lower temperature, the the liquid will reach the end of the thermometer. So the range will be less. It's, and when the range becomes small, the thermometer becomes more sensitive. So it has a greater sensitivity, but a smaller range. because the liquid will be expanding more. So I think B is the right option. Question number 16, B is the right option, sir. So we were on question 16, and you have put a liquid which expands more. So at a lesser temperature, the liquid will reach the end of the thermometer. So the sensitivity will be greater, but the range will be smaller. So B is the choice. Question number 16, let's check. Question number 16, B is the right choice. Question number 17, what is the usual symbol and what is the unit for the heat capacity of an object? The heat capacity is represented with the capital C, and you remember the specific heat capacity is represented with the small c, but the heat capacity is represented with the capital C, and the unit is joule per degree centigrade. Joule per degree centigrade. So I think A is the choice. Question number 17, A is the choice. Question number 17, A is the choice. The heat capacity is the amount of heat required to raise the temperature of a body through 1 degree centigrade. So the unit is joule per degree centigrade. Okay, so which row describes the arrangement of particles and the forces between the particles in a solid? In the solids, the particles are arranged in a regular pattern, and the forces between the particles are strong. So I think A is the choice. Question number 18, A is the choice. Yes. Question number 18, A is the right choice. A simple and straightforward question. He says a wave in the sea collides with the cliff. The crest of the wave hits the cliff once every 6 seconds. So this is the time period of the wave given. 6 seconds is the time period of the wave. So if you know the time period, you can find the frequency. The frequency will be 1 by t. The horizontal distance between a crest and the adjacent trough of the wave is 4.5 meter. The distance between a crest and the adjacent trough is half the wavelength. So that's 4.5 meters. So the full wavelength will be 2 times 4.5, and that will be 9 meter. What is the speed of the wave? The velocity is v equals to f lambda. So let me show you v equals to f lambda. Okay. So the time period of the wave is given, that is 6 seconds. So the frequency will be 1 by t, that will be 1 by 6, and that will be 0.166 hertz. And half the wavelength is 4.5. So the lambda full wavelength will be 2 multiply 4.5, and that will be 9. And the velocity of the wave is v equals to f lambda. So that will be 0.166 multiply 9, and that will be 1.5 meter per second. 1.5 meter per second. 1.5 meter per second. So question number 19, D looks the right option, sir. Question number 19, D is the right option. Okay, so we are going to the next question. The next question is a sound wave refracts as it passes from air to water. So which quantity changes when the sound enters from air into water? The sound travels faster in the water as compared to its speed in the air. So because the speed will increase, the wavelength also increases and the frequency do not change. So which quantities change? The speed and the wavelength. B. The frequency do not change. B looks the right option, sir. Question number 20. B is the right option. Question number 21. An object is viewed through a thin converging lens. The diagram shows the paths of the two rays from the top of the object to an eye. So it's a converging lens. So the object is here. The rays on this side of the lens, they are not converging. So they will not intersect on this side. So, but when you prolong them behind the lens on the same side where you have the object, they will intersect. So the image will be here. This image will be a virtual image. This image will be a magnified image, and this image will be upright. So it's a virtual, upright, and magnified. So it is large. It is larger and inverted. It's not inverted. It is larger and upright. Yes. B is the right option, sir. It is smaller. No. It is smaller. No. So B looks the best option. It is in larger and upright. So question number 20, B, 21, B is the right option. Question number 21, B is the right option. Okay, question number 22, a ray of white light enters a prism as shown. So when the white light enters here, so it's here, it has split it into its constituent colors, and we call it the dispersion of light. And here, you have the red light, and this is the blue light. The red light's wavelength is higher, and the blue lights, as compared to the wavelength of the blue light, and the frequency of the blue light is higher as compared to the frequency of the red light. So which row is correct? Wave properties observed. So here the dispersion happens and the refraction of the light also happens. So it's dispersion and refraction. And he says the frequency of the red light compared with the frequency of the blue light, the frequency of the red light is smaller than the frequency of the blue light. So it's dispersion and refraction, and the frequency of the red is smaller than the frequency of the blue light. So I think C is the right option. Question number 20, I think 22, the C is the right option. Question number 22, C is the right option. Okay, so we go to the next question. The next question, question number 23, which waves are not part of the electromagnetic spectrum? The electromagnetic spectrum is Ronald McDonald is very ugly except Gary. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. So which is not the part of electromagnetic spectrum? Radio wave is, television signals are the part of the electromagnetic spectrum. Ultrasound, yeah, ultrasound is not the part of the electromagnetic spectrum. Ultrasounds are sound waves. So C is the right option. Question number 23, C is the right option. I mean, C, ultrasound is not the part of the electromagnetic spectrum. So question number 23, C is the right option. Question number 24. A man stands between two tall buildings, P and Q. He is 50 meters from P and 200 meters from Q. Okay, so what happens here? He sounds a horn, and he hears the first echo from building P, and 1 second later he hears the first echo from the building Q. What is the speed of the sound calculated using this information? Okay, let me show you. Okay, so here is the man standing. This building P is 50 meter. Building P is 50 meter away, and building Q is 200 meter away. So the sound will go from here and reflect. So the sound will travel 50 plus 50, 100 meter. And in the sound which went in this direction, it will go 100 meter, and then 100 meter it will come back. So the total distance traveled for the sound which is reflected from the Q is 200 plus 200, 400 meter. So the difference of the distance between both the waves, sound waves, is they have the distance they have covered. The difference between that is 400 minus 100, that is 300 meter. The time difference, the time lapse between both the echoes to reach the man is 1 second. So the speed is distance divided by time. So the difference of distance is 300, and the difference of time is 1. So it will be 300 meter per second. 300 meter per second. 300 meter per second. So 300 meter per second. So B is the right option, sir. Question number 24, B looks the right option. Question number 24, B is the right option. Okay. It says sound travels at different speeds in each of the three states of matter, solid, liquid, and gas. Which row shows where the sound travels fastest and where sound travels slowest? The sound always travels fastest in the solids and slowest in the air or in the gas. So the fastest speed of the sound will be in the solids and the slowest speed of the sound will be in the gas. So I think D is the right option. Question number 25. Question number 25, D is the right option. What is one of the uses of the ultrasound? The ultrasound are used to clean jewelry. Yes, that's true. Percent tubes, no. Optical fiber, no. Sunbeds, no. The ultrasounds are used to clean jewelry. So I think A is the choice. Question number 26. A is the right option. So our answer is right. Which material is used for the core of an electromagnet? For the core of the electromagnet, we always use soft iron. And so C is the choice. Question number 27. We use iron because iron is a soft magnetic material. It gains magnetism, and when you stop the electricity, it immediately loses its magnetism. So for the core of the electromagnets, we always use soft iron. So C is the choice. Question number 27. C is the right option, sir. Okay, so we are going to next question. He says two metal spheres are mounted on insulating stands. Sphere X is initially uncharged and the sphere Y is initially positively charged. A metal rod held by an insulating handle is placed in contact with the X and Y as shown. Okay, so the X is neutral and the Y is positively charged. So when you touch these, some of the electrons from the X will go to the Y and some of its positive charge will be neutralized. But still the Y will be positive and the X will also has lost electrons, so it will also become positive. So both of them will become positive. So I think A is the right option, sir. It's a tricky question. Question number 28. A is the right option. Both of them will become positive. Question number 28, A is the right option, sir. Okay. So the next question coming up on your screen is, which device involves the use of static electric charge? A computer hard disk drive, it uses magnetism. A motor, it uses magnetism. A photocopier, it uses static electric charge. A transformer, it uses magnetism. So I think a photocopier uses static electric charge. So C is the choice. Question number 29, C is the right option. Okay, so we are going to the next question. In the next question, okay. So in the next question, it says an initially uncharged copper rod is placed in a uniform electric field. E, the rod is parallel to the field. Which diagram shows the charges induced on the rod? So when you put that in the electric field, so because the electric field is going from the left to right, so the left end should become negative and the right end should become positive. The left end will become negative and the right end will become positive because this is the direction of the electric field. So I think D is the right option. I think D is the right diagram. This question number 30, D looks the best option. It's a little tricky question. So D is the right option. Question number 30, D is the right option. Okay, so we are going to next question. The next question is that the diagram shows a simple electric circuit. Which row describes the charge on an electron? The charge on the electron is negative, and the direction of the electron flow through the resistors. The electron flow is also always from the negative terminal of the battery. to the positive terminal of the battery, the electron flow will be from Y to X. The electron flow will be from Y to X. So the charge will be negative, and the charge will be negative, and the direction of the electron flow will be from Y to X, from negative to positive. So I think B is the right option. Question number 31, B is the right option, sir. When the flash on a camera is used, a charge of 1.5 coulomb flows for 0.0030 seconds through the flash lamp. The average voltage across the flash lamp is 3600 volt. What is the electric energy supplied to the flash lamp? And what is the average power supply? So we know the charge, we know the time, so I can find the amount of current. So let me show you question number 32. Okay. So we know that the charge flowing is 1.5 coulomb, and we know the time taken is 0.0030 seconds. So the current will be charge divided by time. So it will be 1.5 divided 0.0030, and you will get the current is 500 ampere. You know the energy is equals to IVT. The formula for the electric energy is IVT. I is 500 ampere, V is 3600 volt, and the time taken is 0.0030 second. When you multiply them, you get 5400 joules. So the electric energy will be 5400 joules. The power will be energy divided by time, so that will be 5400 divided by the time is 0.003 seconds, so it will be 1.8 x to 6 watt. 1.8 x per 6 watt. 1.8 x per 6 watt. 1.8 x per 6 watts, and the energy will be 5400. So I think D is the right option, sir. Question number 32, D is the right option. Yes, our answer is right. What is the unit of the potential difference, and which measuring instrument is used to measure the potential difference? The unit of the potential difference is volt, and the instrument we use is voltmeter. So its unit is volt, and the instrument used is voltmeter. So D looks the best option, sir. Question number 33. D is the right option. Question number 33, D is the right option. Okay. The diagram shows 4 circuits. Each circuit contains 3 100 ohm resistors. Which circuit has the smallest total resistance? The smallest total resistance is in that circuit where all the 3 resistors are connected in parallel to each other. So C is the right option, sir. Question number 34, C is the right option. When you connect the resistors in series with each other, if you connect them, all of them in series, the resistance of the combination will be lowest. So C is the best option, sir. A metal kettle is plugged into a main socket. The plug contains a suitable fuse. The kettle's cable is damaged and the fuse blows. Why does the fuse blows? The fuse will blow if the live wire will come in contact with the earth wire or with the body of the kettle. And both means the same thing. Why does the fuse blows? The bare earth wire in the cable, the bare live wire, that is possible. Yes, that can be the answer. The metal casing of the kettle touches the bare earth wire. No, this cannot cause the fuse to melt. The bare neutral wire in the cable touches the bare earth wire. No. The live wire breaks without touching any other wire. No, that cannot blow the fuse. The fuse will blow if the earth wire and the live wire come in contact with each other. So I think A is the best option, sir. 35. A is the best option. Okay. As a magnet is moving into the coil of wire as shown, there is a small positive reading on the sensitive ammeter, which change must increase the size of the reading. Moving the opposite pole into the coil, no, it only changes the direction of the EMF. Pulling the magnet out of the coil, it will change the direction of the EMF. Pushing the magnet in faster, yes, it will increase the reading on the ammeter. It will increase the reading on the ammeter if you move the magnet faster. So pushing the magnet in faster, yes, that is right. C is the best option. Unwinding some of the turns of the wire. That cannot increase the current. That will decrease the current. Okay, so I think pushing the magnet in faster, C looks the best option. Question number 36, C is the right option. Yes, C is the option. Okay, so question number 37, the diagram shows circuit for a model power line with two transformers and a lamp at the output. What is the input voltage? So the input voltage of this transformer is question. And there are two transformers. One transformer is here, one transformer is here. So their question is, what is the input of this transformer? So what is the input here? The output of this transformer is 24 volt. The turns on the secondary are 40. The turns on the primary are 200. So I can find the voltage in the primary here. And then same voltage will be here. I will find the primary voltage here. Okay. So in this, first of all, I will find the primary voltage here. So let me show you my solution. I hope you understand. So the voltage in the primary divided by the voltage in the secondary is equals to the number of turns in the primary divided by number of turns in the secondary. So the voltage in the primary divided by the 24 equals to 200 divided by 40. So the voltage in the primary will be 200 multiplied 24 divided by 40, and that will be 120. So the voltage here is 120. So the voltage here is 120. So this is 120. I will try to find out how much is the voltage here. Now we talk about this transformer, this secondary for this. And this is the secondary, and for this transformer, this is the primary. So here you have 120. Okay, so voltage in the primary divided by voltage in the secondary is equals to the number of turns in the primary divided by number of turns in the secondary. So voltage in the primary is question, the voltage in secondary is 120, and the number of turns in the primary is 10, the number of turns in the primary secondary are 100. So the voltage in the primary will be 10 into 120 divided by 100. That will be 12 volts. A very tricky question, question number 37. So our final answer is 12 volt. So C is the right option. Question number 37, C is the right option. I hope you understand. C is the right option. Question number 38. Electric power is transmitted by cables over long distances at very high voltage. What are the effects of using high voltage transmission system? Power loss in the cables reduces. That's why we transmit the electric and electricity at a very high voltage. And current in the cables, when you increase the voltage using the transformer, the current decreases. You increase the voltage, the current decreases. And the power loss in the transmission lines, that also reduces. So the current will be low, the power loss in the cables will be low. And it looks D is the right option. Question number 38. The power loss will become low, the current in the cables will become low. So 38D is the right option. Yes, 38D is the right option. Okay. He says the diagram shows a beam of electrons about to enter a magnetic field. The magnetic field is directed into the page. The magnetic field is represented with the crosses crosses means that the magnetic field is going into the page. And a beam of electron is coming from the left side. What is the direction of the deflection of electrons as they enter the magnetic field? We will use the left hand rule. So I will take my left hand and I will stretch these fingers mutually perpendicular to each other. We call it Fleming's left hand rule. So this is called FMC, FMC, FMC. So the magnetic field, M stands for the magnetic field, F stands for the force, and the C stands for the conventional current. So the magnetic field is into the page. The beam of electron is going from the left to right. But in this law, we don't use electron flow. We take the direction of the conventional current. So the direction of the conventional current will be from right to left. So, and my thumb is pointing downward. So it means that the beam of electron will be deflected down the page. The beam of electrons will be deflected towards the bottom of the page. So where are the options? Down the page, D is the right option, sir. Question number 39, D is the right option. Okay, so here we have in the Geiger-Mortensen experiment, alpha particles are fired at a thin gold sheet. Okay, most alpha particles pass straight through the thin gold sheet. A few are deflected. What can be deducted from this experiment? From this experiment, they concluded that most of the alpha particles straight through the gold sheet, and because most of the space in the atom is empty, and there is only a small mass in the center of the atom, and that is called nucleus. So the nucleus is very small as compared to the size of the whole atom. So what they deduced that the nucleus is very small. The nucleus has no charge. No, the electrons surround the nucleus. No, the electrons have a negative charge. No, these are not the things which they were deduced from this experiment. From this experiment, what he concluded, he deduced that the nucleus is very, very small as compared to the size of the object. So I think A is the right option. Question number 40, A looks the right option. Let's check. Question number 40A is the right option. So, my dear students, the question number 40, we are completed with the question number 40. So, in this video, in this session, we have done May-June 2022 Physics 5054 or 1-1 paper. In this single video, we have been able to complete the whole paper. So if you find this video interesting, useful, informative, and it has benefited you, please share the link of this video onto your Facebook and onto your Twitter accounts and onto your Instagram. That will help me promote my channel. I think it's a great blessing for me that I can help some students around the globe in their physics and in their mathematics. So thank you very much, everyone. Have a good day. God bless you all.